Welcome to this PowerPoint presentation on process control and simulations, which is a course offered by the Chemical Engineering Department here at the Kwame Nkrumah University of Science and Technology. This course is titled CHE 456 and it is a 4th-year course being offered in the Bachelor's of Chemical Engineering curriculum. So I'll be your host for this session. I am Yonji Allen, one of the group members of the IT project group 31. Next slide. In this presentation, the following is our outline. We are going to start with an introduction, definition of various terminologies, various courses, the applications of process control and simulation, the importance or the relevance of what relevance is it to the chemical, biochemical, biotechnology, and research field in general. Then we are going to end our presentation by looking at various recommendations, what you need to know about this course and how to excel. Yes, and how to excel in this course. Next slide. Process control is a field you can't joke with if you want to become a real world expert in chemical engineering, because obviously everything in the chemical industry revolves around process control. Yes, process engineers are in fact very close to chemical engineers. So as a chemical engineer or an aspiring chemical engineer, you must know process control and simulations. Yes. So the James Watt steam engine was what pioneered process control. So it is a field with tremendous possibilities and endless potentials. Process control is really a field to adventure in. So process simulation dates back to World War II when studies were being carried out at the atomic and nuclear level. So we all know during the World War there was need for innovation, production of bombs, various like innovations were being carried out during that time period. So you see, we needed process engineers, yes, process engineers at that time. When we even look at the history of chemical engineering, we look up to people like the Haber, yes. I think he's Robert Haber. Yes, he was the one that pioneered the Haber process, the production of ammonia, yes, from liquid nitrogen and hydrogen. So you see, mostly everything at that time revolved around process control, process simulation. How can you simulate an atomic bomb before like sending it out? Yes, like how? So like there was a need for process control and process simulation. So that's a little bit of history. Next slide. Okay, in process control, we have several terminologies like loops, uh, feedback loops, and several things. So, what is process control? Process control simply involves the monitoring and manipulation of process variables in order to achieve a desired product. So process control is simply what? You monitor and you manipulate process variables so as to achieve a desired product. Let's say you want to produce ammonia. You need to monitor the temperature, the pressure. You need to take into account Le Chatelier's principle, which governs the direction, yes, or the shift of equilibrium. So you need to monitor all these variables, which are temperature, pressure, volume, concentration of reactants. So you see, all of that deals with process control. I don't know if you get it. Now, what is process simulation? In a layman's language, you can say process simulation is just like replicating a chemical process using mathematical models and softwares. Yes. But in the chemical lexicon, we can look at it as the digital replica of a chemical process or plant via the use of mathematical models, computer softwares in order to predict the behavior and to test the scenarios of these uh, processes so as to optimize what performance. So you just replicate a process and then you simulate it using mathematical models, softwares like Aspen Plus and the Hisense and other softwares. Now, the various courses which are being offered under uh, this mother course, which is process control and simulations. So here at the Kwame Nkrumah University of Science and Technology, process control and simulation is a very fantastic and phantasmagorious course which you can study in your 4th year. And once you've excelled in this course, you can like be sure, yes, you can be sure of yourself that you like mastered process control and simulations, because the Kwame Nkrumah University of Science and Technologies Department of Chemical Engineering, under the flagship of the College of Engineering, has one of the best laboratories, yes, in Africa when it comes to chemical engineering. In fact, we are ranked among the top 10 laboratories in Africa when it comes to chemical engineering. And in terms of West Africa, like, we have one of the best, yes, one of the best laboratories and infrastructure in terms of chemical engineering. So uh, the courses or the various topics which are of key interest in the process control and simulations major course at the Department of Chemical Engineering 4th year include: you have Laplace transform. Yes, Laplace transform, which is like an equation that you must like vary some variables, use some calculus, multivariable calculus, in order to solve that transformation. We have some feedback controllers. We have design of feedback controllers, process identification, the Z transforms, root Hurwitz stability, which is a fantastic tool. We have the Cohen-Kuhn tuning. Yes, the Cohen-Kuhn tuning. Pardon me for my grammar and pronunciation. We have sampling of continuous signals. We have the quarter decay, very important topic. We have inverse response. We have transfer functions. We have digital computer control. We have stability plots. Just to emphasize a little bit on this, like when they talk about digital computer control, it is a very huge topic, yes, under process simulation and control. That's where you like explore the world of computer, IT. Yes, you explore that world in chemical engineering. You get to uh, familiarize yourself with softwares like MATLAB, Aspen Plus, Hisense, and several other fantastic softwares that are going to help you excel in the course. Okay, next slide. So the various recommendations, the do's and the don'ts, I would advise any incoming 4th year chemical engineering student here at the Kwame Nkrumah University of Science and Technology College of Engineering is, first of all, make sure you attend all your lectures. That one is obvious. Make sure you attend all lectures. Yes, don't skip, don't remain in your hostel for sake of whatsoever reason. Try and be there. Yes, don't count on friends, because they can fail you and you don't want to mingle with this course, because this is a huge cost. If you joke with it, you can bring down your CWA tremendously. I'm speaking from experience. So the next advice I would give to you is do all your assignments. Yes, we know that. Do all your assignments. Read texts at the library. Yes, the College of Engineering here has a very fantastic library which you can explore. Um, a lot of textbooks are being available. You can read to like edify yourself, yes, to like better appreciate what you are learning, yes. But before reading the text, make sure you first read your slides, because that one is also important. Make sure you go through your slides. Yeah. So like those are my various recommendations. Next we go to what relevance? Yes, what is the relevance of process control and simulations? Because we've heard of the big name simulating, you simulate something, but of what relevance is it? Yes. So, like, first of all, before going to that, I would like to draw your attention on something. There are several types of process controls. We have the feedback control. I think I should have said this in the earlier slides, but just take note of this. We have several types of process controls. We have the feedback control, the feed forward control, the open loop control, the closed loop control, the PID, proportional integral derivative control, which is top notch. We have the on and off control, we have the cascade control, the ratio control, the split range control, and lastly, which is very important, and it's like what is ruling over the chemical engineering industry right now, is the advanced process control, APC. Yes, advanced process control. So like now, what is the importance of process control and simulation? It ensures safety, optimizes production, improves consistency, scales up processes. Let's say you want to produce ammonia, for example. Via process control, you are able to avoid some hazards. Yes, you are able to optimize production. Yes, because if you can vary the temperature, the pressure, the volume of the reactants, in this case for ammonia is nitrogen and hydrogen. If you are able to vary those reactants in proportions that can optimize the production of ammonia, then you obviously improve the or scale up the process. Yes, you scale up the process, because with process simulation you are able to simulate what will be going on in the plant. Yes, via software you simulate, you know that, oh, if I vary this is how the quantity of ammonia I'm going to get. So like you optimize production, you improve consistency. Yes, let's say you produce these uh, uh, ounces of something this month, and then next month someone calls, a supplier demands that very amount, and you are unable to be consistent. So like it would baffle your market. So process simulation and control is very important. Okay, next slide please. Okay, what are the applications of process control and simulation? Already, process simulation, it helps in reactor simulation, heat exchanger simulation, computer fluid dynamics. Yes, when you want to get into advanced research in the chemical industry, mostly areas pertaining to biochemical engineering, biotechnology, nanobiotechnology, what's the other field? Can you remind me, please? Okay, other fields like process engineering. Yes, you need to apply a lot of computational fluid dynamics, which is a top field. You can't joke with that. So that's an application of process control and simulation. You are able to simulate a reactor. Yes, let's say you want to produce a reactor that is going to like ferment this certain amount of let's say this certain amount of matter, yes, or whatsoever chemical you wish to experiment on. You need to simulate that via softwares like Aspen Plus. You simulate to know that, oh, if I do this, I will get this. Okay. So heat exchanger simulations, yes, heat exchangers are very important. Yes, so you are able to simulate what goes on once you use this specific or specified heat exchanger. You are able to simulate, and by so doing, you avoid some unnecessary expenditures and costs associated with not getting proper heat exchangers. So you are able to simulate and to know specific equipments which you need. Okay, so ladies and gentlemen, having said this, I would like to thank you very much for your time and your kind attention. We appreciate the College of Engineering, and my sincere gratitude to our doctor, our lecturer, uh, Dr. Bonsu. Yes, Dr. Jude Bonsu, for the privilege he gave us to like bring up this PowerPoint presentation, and I hope it is going to go a long way to assist you in getting into the Department of Chemical Engineering here at the Kwame Nkrumah University of Science and Technology. So, ladies and gentlemen, if you want to know more about the College of Engineering here at KNUST, you can follow us on YouTube, LinkedIn, and feel free to engage with alumni, peers, current students, graduates, undergraduates, and lecturers in case you need whatsoever assistance. And see you in subsequent presentations. Thank you very much and stay blessed.